So today what we're going to do is we're going to look at one of the reasons we study probability. Because we've done a lot of probability, but we haven't really done a lot with probability yet. And so we're going to look at something called absolute and relative risk. And so we're going to go through a lesson with this. You're going to find that it's simply a ratio, just like any other probability. A ratio is simply another word for starts with an F. Fraction. There you go, right? Your job, though, is to make sure that you get the right piece in the right place and that you make sure that you always simplify them. But with risk and relative risk, because usually you don't say absolute risk, you just say risk and know that means absolute risk. Relative risk, however, has to be defined. So make sure you recognize that they're two different things. Now, they are usually given as a whole number or a decimal, right? They are not probabilities, which means they can be bigger than what number? What's the highest number you can have for probability? 1 for a probability, right? So they can be bigger than 1. You can have a relative risk or that's bigger than 1, okay? So remember, these are specific types of information using probabilities. They're not probabilities in and of themselves. What does it mean if you have a risk? Anybody want to have a... Sure. So something could happen. Exactly. Right? And now, that risk could be good or bad, right? Usually when we think about risk, we associate it with bad things. I've got a risk of getting sick, or I've got a risk of getting run over in the street, whatever, right? Okay? We generally associate it with bad things, but that's not always the case. Okay? So, absolute risk kind of corresponds, hold on just one second, kind of corresponds to our theoretical probabilities, right? Absolute risk is just the mathematical risk, okay? Whereas relative risk, if something is relative, it's relative to something else. In other words, it's a comparison, right? Anytime you see that word relative, always think of a comparison. And we'll define these as we go through, so through the lesson as well. Yes? What was your question? Sorry.
What was the thing that was usually given as a decimal or
a decimal or a whole number. Many, many times it only makes sense if you round it to the nearest whole number.
Is that for both absolute and relative?
Yes. Mm-hmm. Okay. And we'll look at examples of that, and they'll talk a little bit more about rounding as well. Okay, so here we go. Let's go to our lesson. All right, so in probability, the risk of an event occurring is just another way of saying the probability or likelihood of an event occurring. Okay, so you think of risk, the risk of something happening, you think how likely is it to happen? So typically prefer the likelihood over probability, but basically it's pretty much the same thing. Okay? So the risk of catching the flu is the same as saying the probability of catching the flu. Okay? Make sense? So it's just another type of probability, but then there's some risks that are not probabilities, so be careful. Absolute risk is the probability of a random selection having the outcome. In other words, it's a mathematical computation of probability, right? And what's absolute risk? It is a probability. So that means it will be between 0 and what? 1. If it's relative risk, that's a comparison. So does it have to be between 0 and 1? No. Okay? So be careful when you're talking about them. And most of the time, you're not going to see the words absolute risk. You're just going to see risk. So that means the theoretical one, the absolute one. So, for example, the absolute risk for New Zealanders developing bowel cancer over a lifetime could be expressed as 0.065%, or roughly 1 in 1,600 of the population. Okay? So that's your risk of developing that particular disease or that particular type of cancer. So you see this all the time. It's one of the reasons we use probability so frequently is to determine risks for certain events. Okay? All right. Relative risk, however, is slightly different. Relative risk always is a comparison, one group compared to another group. And there are a couple of things that we need to be familiar with. Remember, vocabulary is going to play a huge part in understanding probability. So when you're talking about relative risk is simply the risk for one group over the risk for another group. So in other words, you're going to have two probabilities, right? The probability for A over the probability for B. And the one at the bottom is really important because that's the one you're comparing to, right? But you're used to this with fractions. The denominator always tells you how many pieces, so that's always the comparison number. So that's the bottom one is called the baseline risk. In other words, it's the thing that everything is based on. Okay? Now, you're going to see a formula that looks like this a lot in probability. If you did odds or expectation, you would see that odds is the same kind of thing. Comparing two probabilities. So anytime you see these relative comparisons, right? Now, relative risk can be what? And frequently is, right? Right. So, absolute risk is a probability between 0 and 1. Relative risk is not a probability, it's a ratio. Therefore, it can be bigger than 1. Right? And this is the one we like to have as rounded generally. You'll see usually you're associating it with the number of people or something like that. Whoops. I'm sorry. What now? Baseline risk, that's what you're basing it on. So let's say that I say that Group B is all the children in New Zealand. So that's what we're basing our risk on. Okay? So it's always the one on the bottom. But you're used to that. The denominator is the number that is the number of a part of the fraction that really drives the fraction, isn't it? The top is just the part. The bottom is the base. Yeah? You've heard that expression, part over base? So the bottom is pretty much always the one that telling you what to do. Okay? So that's the baseline risk. So here we go. Let's look at an example of absolute and relative risk. Here in an example, here we have a two-way table. It says the university offers courses in which can be studied on campus by attending the lectures or remotely through a distance learning program. The table shows the pass rate using these options. So notice that they have it divided up. You've got lectures or remote, and then pass and fail, and the bottom column and the end column and the bottom row are always totals. Be careful with that, okay? Make sure that you don't forget that those are always your totals, okay? If you're watching this recording, the internet is really slow today, the Wi-Fi, so this screens are not matching what I'm saying. But here we go. So now we have we have this up there, and we have all the numbers filled in, so there's nothing missing, right? What if there were pieces missing?
You have to fill it in.
Exactly, and be prepared to do that, right? Sometimes they'll give you some of this information, but not all of it. So what we want to look at are just looking at some of the overall risks and relative risks, etc., for using these. All right? Now we're just going to go through these. Worked out. So let's look at the first one. What is the overall risk for failing a course? Now, overall means what? Total everything. Yeah? So am I just talking about lectures? Or am I just talking about the online? Nope. We're talking about anybody who failed the course out of everybody who took a course. So how many total students were there who failed a course? 124. Good. Out of how many total students? 415. And notice then they changed that to a decimal. And notice it is less than 1. It's between 0 and 1 because this is a probability. It looks exactly like the probability we did before. This is probability of failing the course, isn't it?
What's the little squiggly equal?
Okay. The squiggly equals, that means about. About. Or approximately. Good question. You're going to see that. And what that tells you is that they did what? They rounded it. Yeah, they're not using the exact answer. And I expect to see that if you do something like that. I expect to see not equals, but squiggly equals the about or approximately. Okay? Good question. All right? What is the risk of failing for students who attend lectures at the university? So, we're talking about students in a specific category, aren't we? What category? Lectures. But we only want we want to know how many students out of all the students who attended lectures who failed. So how many failed? 75 out of how many? 262. And so there you get your probability. All right? So you see that risk is simply, absolute risk is simply a probability. Nothing different from what we've done before. Okay? What is the risk of failing for students who study remotely? So, remote is, the failing rate is 49 out of how many? 153, which then they simplify. Okay. Now, just looking at those two pieces of information, is there any conclusion that you can draw based on those two failure rates? Yes, if you're in the remote class, you're slightly more likely to fail, aren't you? Okay. So 32% of them failed versus 28%. It's not a huge difference, but significant. Yeah? Okay. Now we want to know, what is the relative risk for failing the course for students who study remotely compared to the risk for the students who failing the course who attend lectures? Now be careful. Compared to means that the one that after the compared to needs to be where? Bottom. On the bottom. There you go. So it's the number who failed remotely over the number who failed while attending lectures. Notice they'll always do this for you as well. They're going to give you these things in pieces. They'll have you compute the probability of one, then the probability of the other, and then you'll put the probabilities over each other, and then there you get your final probability, or your final, relative risk. Notice it's bigger than one, yeah? Okay? So be careful. It can be bigger than one, so you can't use that little rule. We'd been using it to help make sure we did the math. A student wants to know if a pass is more likely for students who attend lectures. What would you tell that student? Yeah. If you attend the lectures, you're more likely to pass than if you took the course remotely. Right? And then they go a little further and say that students who study remotely are 1.1 times more likely to fail than those who attend lectures. Now remember, this is not a pass rate, this is to fail. So 1.1 times more likely than those who fail. Where do they get that number? 1.1. All right, it's 1.118. They just rounded it to 2 decimal places. Now, did they tell you to round it to 2 decimal places anywhere? No. So they're just arbitrarily picking 2 decimal places. So you're not going to be sure where they're going to round them. Right? How's it look? How easy is that? More of the same, right? It's just about getting the right thing in the right place, which sounds very similar. All right, very familiar, I mean. Here we go. Absent relative are often used in medical scenario, and that's where we usually think of risk, right? We think of risk of catching a disease or something. So here we go. We have a table of drinkers and non-drinkers, and those who have liver cancer and have no cancer. And then, of course, we have the totals. So the table below shows the data for the study of drinkers. Calculate the relative risk of having liver cancer for a drinker compared to a non-drinker. So here's what I want you to do. They'll do this for you, but I want us to get our hands wet, right? So you guys will we'll split it in half. I don't know how to do it. You guys over here, including you two, will calculate the absolute risk for having cancer if you are a drinker. Okay? Having cancer, have a drinker. You guys, absolute risk of getting cancer for a non-drinker. Go. It should take about 2 seconds. So, for a non-drinker having cancer, right? And you guys for a drinker who has cancer. Okay? All right, so who over here at this table wants to tell me what numbers did you use? So you did the drinkers. So in order to get the absolute risk, you needed to put the number of people who what? Who had cancer, which is what? 367. Amanda, and guys, what over what number?
Over the total, which is 700.
Over the total, which is 7,000. Excellent. And you got a decimal? What'd you get? Anybody? Okay. All right. I'm going to write that down. What? I'm sorry. Can you repeat that again?
0.0483.
Okay. Or 484 if you rounded it differently. 484. Okay. Thank you very much. All right. So they rounded that to 4 decimal places. Okay. Now, that again was for drinkers who got liver cancer. So it's just that number over the total. All right, you guys over there, what did you use as your numerator, your top number? 22 over what?
4,530.
Which gave you?
0.0049 to 40.
Okay, so 0.0049. Okay. All right, we happy with those numbers? And those are not relative risk, but what? Absolute risk. Just a simple, straight probability. Okay? Now, but that's not the question they were asking us. They were asking us to compare for the relative risk of having liver cancer for a drinker compared with a non-drinker. So we have drinker compared to non-drinker, right? Is it important that I put them in the correct order?
Yeah.
Absolutely. So all I'm going to do is put this first number over the second number and do the math. And we're going to round, so I'm going to put the about. Anybody want to give me a number rounded to
9.88.
9 point what? 88. Do you all agree? Okay. All right. So that tells us then that a drinker is almost what? Almost 10 times more likely, right? To develop liver cancer than a non-drinker. Now, when you just looked at it like this number, here's the probability, 0.0484, you went, tiny little number, right? But when you look at it using relative risk, what do you think? 10 times more likely? A lot higher, isn't it? Yeah. And that's one reason we use these comparisons, is because it gives us a chance to look at things using numbers that make more sense. Probabilities frequently don't make much sense to us on their own. But when we do these relative risk assessments, then what happens is we're able to look at things using a multiplier which fits better with our perception. We're not good at little tiny numbers or what? Great big numbers, right? So being able to use these comparisons puts it into a scale that is familiar to us and makes sense. What happens if you hear a number like, so-and-so is worth $500 billion? I mean, that's a lot of money. You wish you had it and they didn't, but does it really mean anything to you? No. But, and same thing for very small numbers. It just doesn't really click to us, doesn't make much sense to us, right? So this gives us a chance to put things into perspective. Good job. So all they did was they just found the two probabilities, got exactly our same information, and got, they got 9.98. Did we do something a little differently? Are they round or something different? Or they didn't round, probably.
No, they didn't round the bottom.
They didn't round the bottom?
We rounded it.
Oh, y'all rounded it? They didn't? Okay, so that changed a little bit. Sorry. So therefore, about 10 times more likely. Yeah, well, we rounded it to the... We still got there in the end, right? About 10 times more likely. All right, how does it look? Relative risk and absolute risk? Feel good about it? Okay, let's look at a couple more applications. It's not going to change, kids. Okay, so 8 out of every 1,000 women have breast cancer. Okay, of these 8 women with breast cancer, 7 will have a positive mammogram. Of the remaining 992 women who don't have it, some 70 will have a positive mammogram. So they don't have it, but they still got a positive mammogram, right? This is something called a false positive. And this is what you're going to see this a lot when you're dealing with risk and relative risk. These positive, the idea of a false positive, okay? So look at what's going on. So if you look at the first column, those who had breast cancer, 7 of them got a positive mammogram. If they have breast cancer, should they have gotten a positive mammogram? Yes. But one of those got a negative. If she had it, should she have gotten a negative? No. So that's a false negative, right? Okay. Which tells us what about the test? That it's not 100% reliable, is it? Okay? Now, using information like this, then we could determine how reliable a test is. For example, there are tests for lots of different diseases and lots of different tests out there. The test you choose might be determined by the reliability of the test. And the more serious something is, what? The more reliability you want, right? Okay? If it's just a common cold, are you that concerned? Not really, right? But if it's something more serious, then you certainly want to have the most reliable test possible. Okay? So imagine a sample of 1,000 women have a positive mammogram. So that's what we've got in our chart. Right? Okay? So how many of these women actually have breast cancer? So we're going to be looking at how many out of 1,000 women. So we're only interested in the women who have a positive mammogram, right? And how many total have a positive mammogram? 77, okay? Out of how many women and how many of those women actually had breast cancer? So 7 out of those 77. So 7 of the women who have a positive mammogram also have breast cancer. Does that surprise you? 70 women who don't have it got a positive mammogram? That seems high, doesn't it? I mean, can you imagine going in and somebody saying, yes, your mammogram is positive, and then being one of those 70 women where it's not? I mean, you'd be really relieved, but you would also be terrified in the beginning, right? Okay. So from this we can find the expected number. Remember, expected number, it's been a while since we did expected number. Expected number is simply the probability times the number of items, right? Or people or whatever you're doing, right? So you just take the probability. In this case, they use it as a fraction times the 1,000 women, and that gave them the expectation. So how many women then will have breast cancer who got out of that 1,000? 90 of them? 90.9, so probably we should say what? 91? Right. When you're dealing with people, we don't like to cut pieces of people off, right? So let's say the whole person. Okay. So 91 women. Okay. Remember the rounding rules. Be specific to what you're doing. If you're just talking about a number, could you round something off? Absolutely. If you're talking about a living being, do we like to round pieces of people off? No. Round up. We don't like to. It's not good. So out of the sample of 1,000 women, we expect 91 of them to actually have breast cancer. Yes? No, because you would actually round that up to the next person because it's 0.9 is almost a whole person. So you don't need the squiggly line for that. Then you're still over the number. If it's people, you're not going to have parts of them, so don't worry about abs. Don't worry about the about. I'm sorry?
Would they downgrade us for it if we're just using it?
I don't think so, but I'll look into it for you. Yeah. I don't think you'd be wrong for saying it, but because remember, if we're rounding this, even if it was 90.1 and it's people, we would round that to what? 91. We're never going to leave any tiny little part of a person left. It's always going to round up. Okay? So it's okay. All right? Sorry, this is... So here we go. Well, that's your question. Never mind. I'm not doing your homework for you. Oh, so sad. Okay? So you get the idea. So be careful. Watch what they're asking for. Are you looking for absolute risk, which is just a straight probability? Good. Are you looking for relative risk, which is a comparison? Or are you looking for an expected number, right? Which means you take the probability times the number of items, how big the sample is, right? So be careful. You've got all of them there. So this is a pretty good review, pretty good way to get you back into looking at probability. All right, let me stop this.